Okay, let's play with some graphs. This is shifting, reflecting, and stretching graphs. Or another way to talk about this is how to graph anything without using your graphing calculator, just in case you don't have it, or you don't have any batteries, or you loaned it to someone, and how can you, or maybe you just want to do this quicker. So we're going to learn about some graphs. Now, we're going to start off today's lesson with 5 graphs that you should know and love. Now, these are what I want to just show you is the basic shapes that you should know, and that you don't have to put these on your calculator because it takes way too long. And the first one, of course, is y equals x squared, and that is your basic parabola. It looks like this. Now, I could talk to you about some points on there, but this is a vertex at 0, 0, some points on here, 1, 1, 2, 4, and some twins on the other side. This is -2, 4, and this is -1, 1. From yesterday's lesson, you might remember that this is an even function. Let's talk about its domain and range, just kind of to review here. Its domain is from -infinity to +infinity, and its range is from 0 to +infinity. And the only, well, no, that's all I'm going to talk about. That's basically your y equals x squared. Now, the second graph you want to know is the opposite of x squared, which is square root. Y equals square root of x. Now, I am going to say this. We are just using the positive square root here. So this graph is like a little wing, and it looks like this. If we put the other piece down here, it wouldn't be a function. So when you graph this on your calculator, you're just going to see the positive wing right here. Again, let's talk about the domain and the range. We could put some points on there. 0, 0 is on there. 1, 1 is on there. 9, 3 is on there, which would be up here. 4, 2 is on there, like right there. You could do a T-chart, and you could see some points. But basically, it's a wing off to the right. Its domain is from 0 to +infinity, and its range is also from 0 to +infinity. So from here, forever to the right, and from here, forever up. That is square root of x. This is an even function. This is neither even nor odd. As you can see, it has no symmetry. Moving on, number 3. I can already tell I'm going to need 2 videos for tonight. Okay, number 3, let's do cube. We've talked about cube a lot. This is cube. It goes from 0 up very fast and from 0 down very fast. This is y equals x cubed. And the domain and range of cube are negative to +infinity for both. We talked about this yesterday. This is an odd function. It has origin symmetry. If you put in a number like 3 and cube it, you're going to get +27. If you put in -3, you're going to get -27. And when that happens, you have an odd function. This is cube. Cube is tall and thin. Gets very big very fast. Just think about how fast cube numbers go. Like 5 cubed is already up to 125. So big numbers fast. This is y equals cube root, and this one I'm adding. This one's not in your book, but I think if you know cube, you ought to know cube root too. So cube root is the opposite of cube, the inverse of cube, and instead of going up very fast, it goes out very fast. And so I just call it a flat snake. Cube is a tall fella, and cube root is a flat snake. Here's some points on here. 0, 0, 1, 1, -1, -1. And then the cube root of 8 is 2. So at 8, you're only up to 2. This is 8, 2. And this is, of course, -8, -2. And the next point out there would be 27, 3. So you see how it's rising very slowly? The numbers are getting big, the x numbers are getting big, and the y numbers are just increasing very slowly. So this is cube root. So cube and cube root, square and square root. That's 4 of the 5. Of course, I've run out of paper, so let me flip this over. Here is the fifth and final one that I want you to be familiar with. This is y equals absolute value of x. This is one of my favorite functions because the absolute value is the v. You know, the absolute value of everything is positive, and so can you look at this graph and see that? Only positive graph is spoken here. There's nothing down here in the negative part. It's all above water, above ground. This is y equals absolute value of x. Here's a point. 5. The absolute value of 5 is 5. And here is the absolute value of negative 5, which is also 5. So you see it is twin. It is also an even function. Put in a number, get out a number, put in the opposite, still get out the same number. So this function is even. Its domain is from negative to positive infinity, and its range, since it's always positive, is from 0 to positive infinity. So this is part 1 of today's lesson. You need to be able to graph and discuss any of these 5 functions, and if you do, it's going to make the next part of our lesson extremely simple. So let's go about making our changes now. Let's talk about how we can shift these graphs. The first change that we want to make to these graphs is called a vertical shift. Vertical shift means, of course, up and down. So let's look at the difference between y equals x squared and y equals x squared plus 4. Okay, now you see the difference in the equation. This is your basic y equals x squared, rooted at the origin. If you put this on your calculator, you would see that the only difference between these two graphs is the addition of 4. And what that's going to do is it's going to pick that graph up 4 units, and so it's going to look like this. A vertical shift is added onto or subtracted from the end of the function. Now, it doesn't have to be at the tail. It can be at the head, too. I could have y equals 4 plus x squared, but it picks up the graph and moves it exactly the amount and in the direction you would guess. So let's say we have y equals absolute value of x minus 3. Now, watch my paper. This is the normal absolute value graph. Remember, I drew it for you a minute ago. It's a V. So this one is shifted minus 3 or down 3. So we're just going to pick it up, move it down, and this is that graph. Now, you see, if you know how to do that, it is so much easier to just do it by hand than it is to put it on your calculator. It's just absurd to do that, to waste time. So this is a vertical shift. It's a constant added or subtracted to the end. If it's added, the graph goes up. If it's subtracted, the graph goes down. All right, that's a vertical shift. Next, let's talk about a horizontal shift. Now, you notice, let me pull this back. When we were doing vertical shifts, we were adding and subtracting outside the function. In other words, x squared, and then we said, oh yeah, let's add 4 to it. Or absolute value, let's subtract 3. Okay, I want to show you the difference between shifting horizontally and shifting vertically. All right, this was the vertical shift, y equals x squared plus 2. Okay, this is vertical. And let me remind you what that looked like. Here is x squared. And here, 1, 2, is the new graph, x squared plus 2. Okay, so this was the original. This is ugly, but you just have to look at it. This is the original, and this is the shifted graph, the new graph. All right, now I'm going to put on this side of the paper y equals x plus 2 squared. And I want to show you the difference. You see how this 2 is like outside the function, and this plus 2 is inside the parentheses? Well, when you have a number added or subtracted inside the parentheses, it produces a horizontal shift. And a horizontal shift, of course, is left or right. And here's the weird thing. Horizontal shifts are contrary in direction. Contrary is a word that means doesn't do what it's supposed to do, like a bad child. You say a contrary child. That child is contrary. Well, it means you tell it to go left, it goes right, or you tell it to sit down, it stands up, or you tell it not to cry, and of course it bursts into tears. So this says, even though it says +2, this means left 2. Because it's plus, you would think would go right, positive direction is right, but because it says that, we're going to shift it 2 to the left. So normally this would be the graph of y equals x squared. This one says +2, so we're going to move that vertex here, and here is the new graph. So that is a horizontal shift. Okay, let's do another one of those. Push this up just a little bit. Let's look at f of x is equal to, let's do x minus 1 cubed. All right, now you know cube is the tall guy. I'm going to just dot what normal cube would have looked like, sort of like that. Now, see how this is inside? So that's a horizontal shift, and it says -1. And remember, horizontal shifts are contrary, so that means we're going to go right 1. So this vertex is going to move here. And so this is what your graph is going to look like. There is the graph of x minus 1, the quantity cubed. That is horizontal shift. And of course, you can combine the two. Let me draw you one more. Let's do y is equal to x minus 1, the quantity squared, plus 2. If that looks like a parabola, it is. And so what we've got is, here's the original, y equals x squared. Okay, now look what it says. This part says up 2. And this part says left 1. So basically you take this vertex at 0, 0, you shift it left 1 and up 2, and here is your new final graph. So that's horizontal and vertical shifting. I'm almost at 13 minutes, so I'm going to stop this video because I got some more to do. So let's end this one and then pick up. You'll have another little piece to watch, so I won't run out of time. So tune in for the second part.